everyone, and welcome to the latest episode of Pavement Matters, brought to you by Pavement Management Services. I'm your host, Mary Jones. Pavement Matters is the show where we discuss all things related to pavement engineering. Today, we have a special guest, Dr. John Yeaman, who is the founding father of PMS. He has made significant contribution to the pavement industry for over 40 years in Australia. Welcome to the show, Dr. Yeaman.
Thank you, Mary.
Can you tell the audience a little bit about yourself, please?
Yeah, my name's John Yeaman. I've been involved with roads all my life. When my father was appointed as Chief Engineer of the newly formed Blue Mountain City Council in 1947, he was determined to traverse every road in the city. Every Sunday, for about 2 years, he would collect my sister and I from Sunday school. Mum had packed us a picnic lunch and we would travel to some part of the city, starting in the east at Emu Plains and finishing in the west at Bowens Creek, Mount Irvine. Dad would make notes about the road and my sister and I would collect wildflowers and rocks from the side of the road. The wildflowers were pressed and the rocks labelled in bottles, each with a description with locality and type. I recall that flannel flowers would only grow in ironstone country, which made for good roads. Boronia would only grow on heavily composted, rich soil, which was difficult to compact, and tree ferns only grew on the south side of a hill in basaltic country, which became muddy after the surface was broken. Christmas bells would only grow on swamp where you couldn't build a road anyway.
That's so interesting. I don't think I knew about it, and I don't know how many of my listeners would know. Dr. Yeaman, will you be able to tell us what is your passion?
Well, my passion is roads.
That's for sure.
All things for roads. Some people say I'm a road scholarship, ROADS, but it really started. My father was determined I was going to be a civil engineer. It took me 20 years to prove he was right. But when I was about 12, he unpacked the P&H stabiliser in our yard at Blackheath. Now, I had the day off school, wacko, to watch the first cement stabilised road being built in Australia. Now, I still watch that road with interest to see how it's going after something like 70 years, and it's still going well. Before that, it was an impassable when it got wet. I joined the Forest Service as a chainman, surveying road alignment for proposed forests, and then I was sent to the laboratory, or sent to the Snowy Mountains scheme as a fire control officer. But on wet days, which were pretty often, I finished up in the laboratory at Cabramatta on the Snowy Mountains hydro scheme. One day they asked for volunteers to be a technician at the asphalt plant, and I put my hand up and got the job.
Wow.
From there, I went to Blue Metal Industries, where I was required to start a laboratory in materials engineering, and during that time, in the 18 years I was there, I got myself a science qualification and a Master of Engineering. From there, I went to SAMI Soil Treatment Services and SAMI, where I earned a PhD in pavement engineering, i.e. maintenance. I hung up my own shingle as Pavement Management Services in 1981 and set about selling this service to local government. In 2008, I sold the business to a Dutch company, Fugro, and was required to continue working with them for 3 years. After the 3 years, in 2001, I accepted a position with a new Sunshine Coast University as Professor of Civil Engineering. This morphed to the Department of Main Roads and Transport Queensland Endowed Chair of Infrastructure Area, and I retired at the age of 80. I now live near Brisbane and am actively involved in creating a knowledge-based system for pavement management utilising machine learning and artificial intelligence.
Yeah, I think it's safe to say that road is your passion.
I would say roads are my passion, yes.
That's interesting. Okay, so we've got a few topics here to discuss. I will say my first question is, how did the AASHO road test refine the PSI, by incorporating factors like roughness, rot depth, and the area of cracking to calculate the present serviceability index, if I can say that word right, PSI.
Younger listeners would probably don't remember the AASHO road test, but at the end of World War II, the American Army had a lot of trucks and a lot of truck drivers, and they didn't know much about roads or maintenance thereof. So they built a test track of about 18 miles with all different types of pavements and structures and materials. And then they had teams of 3 people go out every day to rate the serviceability of the sections on a scale of 1 to 5. Eldon Yoder, of the famous textbook person, was researching the test for Purdue University. He opinioned that lay raters were much easier on condition than highwaymen, and that you needed at least 8 to 11 raters to get a permissible error of 0.5 numbers. Francis Beam of Caltrans, one of the smartest guys in the pavement area, suggested that users were only concerned with roughness, and that is all we should be measuring. Ron Carey, a statistician on the road test, argued that visual rating was far too subjective for ride quality and introduced the concept of present serviceability index, which was a function of roughness, cracking plus patching, because patching was prima facie evidence that there was a distress in the pavement, it had only just been repaired, and the slope variance of rut depth. This is a complicated algorithm, and as roughness was in inches per mile, the conversion to international roughness index units, which are metres per kilometre, complicates it even further.
That's a great information for our young listeners. Dr. Yeaman, thank you. How does PMS today utilise the LCMS technology to calculate the PSI?
Yeah, PMS has adopted this latest LCMS system as the best equipment available. It uses multiple lasers to generate a picture of the road surface. This allows a vast range of outputs, some of which are roughness, rut depth, and visual of cracking and patching. This equipment now makes the use of the PSI redundant, as we can now report the physical properties of road surface very accurately. Why not just map roughness, rutting, cracking and patching in 1 to 5 bands of good, fair, poor, very poor and terminal?
Thank you. And Dr. Yeaman, will you be able to tell me and our listeners that how World Bank uses the PCI to simulate the deterioration, please?
Yeah, the World Bank has put a lot of effort in developing what they call the Highways Design and Maintenance Model for modelling pavement behaviour. They will not loan money to developing countries unless they have HDM installed in their software. Everything from time to initiation of cracking to cracking failure, to name only one of perhaps 60 models, have been developed by the World Bank. From that, the PCI was originally used to start as the starting block for deterioration, and thus, with knowing these other algorithms, you could calculate the condition for every year that you were looking for into the future. And this allows us to go back to things such as rutting, the development of rutting, and the development of the first rut, and then the increase of rutting with time. Very, very powerful tools, and PCI was the starting block.
Thank you. Thank you so much. And how was the green worm employed in your PSMC contract for controlling network roughness?
This is an interesting one. When we first joined the bid process with Transfield for the Sydney Performance-Based Maintenance Contract, PSMC, we soon realised that the benchmark data with which we had been supplied was heavily reliant on roughness. They used the NASRA car for IRI, where about 30 NASRA accounts were 1 AASHO, so it was a very fine measurement of roughness. Although we were going to use HDM4 for modelling, then why not just use the fundamental parameters rather than abstracts such as the PSI, which was heavily weighted on roughness anyway. So we used all the algorithms of HDM4 to predict the condition and every type of distress over the 10 years of the maintenance activity, subject to other maintenance activities. I mean, once you filled a pothole, it was no longer a pothole. That had to be monitored, and what available monies. And we had to give Transfield one number, which would be their contract price for the 10 years of the contract. So it was critical that everything would be absolutely correct. And roughness was a critical KPI.
How long was that contract for, Dr. Yeaman?
The contract was 10 years, and we served for them for the whole 10 years. It was extended by a further 8 from the success of our work.
And you set the KPI for those network as well?
I set the KPIs for that network, what we were going to achieve. And one of these things was a chart for roughness in NASRA accounts against each year for the 10 years duration. Originally, it was in red, but the person at the DMR who is evaluating the contract was red-green colourblind, and he named it the green worm, so we let the name stick.
That's really interesting. That's really good. So you managed to improve the network or keep the network safe and serviceable at the range of the KPI that you guys predicted. Is that right?
That's correct, and that was purely using the models and the condition. We became more sophisticated over time with the equipment that we used to measure it. We went from a 3-beam laser to a 5-beam laser to a 14-beam laser and then a 21-beam laser, but it was still essentially the same thing. Nowadays they talk about 40-beam lasers.
Yeah, well, we have a laser equipment now that has got 4,000 points.
Yeah, 4,000 points, Mary tells me. That's a hell of a lot better than we had, which were 5.
Well, that's when the technologies evolve, and where we're going with the machine learning and artificial intelligence for our next step.
Yes, so I see that this, and back in the days when I first wrote my dissertation, Ronald Hudson, the father of pavement management, said, "Oh, well, John, this is ideal for artificial intelligence." I didn't know what artificial intelligence was, nor did I really care. When I was a professor, I got to hate artificial intelligence because I'd set an assignment and I would get 10 identical answers. Obviously, ChatGPT was being used far more than knowledge, and I felt my students were really only learning how to operate a computer rather than learning the subject. So I got to hate it. But when I saw what John was doing, I've come to love it, and I'm really enjoying the task of putting this knowledge into artificial intelligence.
Yeah, and we're going to achieve all that for pavement management services at the next level. Well, thank you. Thank you so much for sitting down with us, Dr. Yeaman, and everyone else who's listening. Thank you for joining us. Please leave a comment below and make sure you subscribe to our podcast. Our podcast is available on Spotify, Apple Podcast, and Castbox. So until further ado, see you next time again. Thank you for listening to our episode.